Hey everybody, this is your review video on 4.1 to 4.2, and on the first one it says determine from the graph whether the function has any absolute extreme values on the closed interval AB, then explain how it's consistent with the extreme value theorem. So when we look at this has a jump discontinuity. In other words, it's not continuous, and there's also no absolute maximum. There's no absolute maximum. And then the minimum occurs at x equal a. Yeah, the minimum is right here, and so that makes it D. There's no absolute maximum, and then the minimum is at x equal a on that. And then explain it in terms of the theorem. The theorem says you have to have it continuous. It does not satisfy the criteria, so then you know it's either A or B. And then this says must, and this says may or may not, and it's may or may not. So that one is like number 5 on 4.1. On the next one, we have a piecewise function with negative 2x and one with 2x minus 3. And here are your intervals. So you want the graph, and if it's negative 2x, that means it's going to be down 2. Okay, this one's not it. Okay, so at this point it's either A or D, and then the next part says 2x minus 3. So if this continued, that would make sense, and if this one continued, it'd be past that. So it's not going to be that one. So it's this graph. So basically from 0 to 1, it's down to right 1, so negative 2x, and from 1 to 2, it's increasing and it's up to right 1, but it has a y-intercept of negative 3. Okay, so that's the correct graph, and then this one has an absolute maximum at x equal 2, but it does not have a minimum. So basically this is your maximum, and it does not have a minimum on that domain. So that's A. And then it's not continuous based on the jump. So based on that, it's not A or C, since it's not continuous on a closed interval or open. It would have to be continuous on the closed in order to work, and so that'd be B. Would need to be continuous on a closed interval. Okay, on this next one we need to graph it. Negative square root 1 minus x squared. And we care about from negative 1 to 0, which is basically the left side. And so the absolute maximum would be 0 at x equal negative 1. And the minimum would be negative 1 at x equals 0. And again, it's the left side of this, and so that's D. Because it was this part from negative 1 to 1, or negative 1 to 0. So, of course, it could not be that one or that one based on the interval from 0 to 1. And this is negative 1 to 0, and this is also negative 1 to 0. But we had the lower side. Okay, on the next one we have x to the 4/3, and we have negative 1 to 8. So on this one, we're going to want to graph it. X up arrow 4 divided by 3. Okay, so that's that function, and we care about from negative 1 to 8. And if we look in our table at negative 1, we get 1. And at 8, we get 16. And if you look at the graph, so let's get rid of the table, we have a minimum at 0, 0. So on this one, from that interval, the 16 is the maximum value. So the absolute maximum 16 occurs at x equal 8, and the absolute minimum, which is 1, wait, it's 0, the minimum is 0, occurs at x equals 0. So basically, 0 is smaller than 1, and so that's why that's the minimum over that interval. Okay. On number 5, it says determine all the critical points for this. And our first step is going to be to rewrite it as x to the 1/2. That way we're able to do our derivative. So that would be 4x minus 4x to the negative 1/2. So basically what I did was 2 times 2 is 4, and then decrease it a power, so 4x, and then negative 8 times 1/2 is negative 4x, and then decrease it by 1. So what that looks like is this. And then we want to get a common denominator. Common denominator of square root of x. So that basically means we need an extra square root of x there. And then that really, x squared of x turns into 3/2. Because 2/2 plus 1/2 is 3/2. And on this one we set that equal to 0. So we have 4x to the 3/2 minus 4 equals 0, because when you multiply by square root of x, that stays 0. And then we move this to the right and divide by 4. So we get x to the 3/2 equal 1. And so then x would be equal to 1. So that'd be your critical point. So again, for reinforcement, if I graph my original function, I get a minimum at x equal 1. So that's how you know it's a critical point. Okay, on our next one we have this. X to the 2/3 times x minus 4. And so I have a spot where it's a cusp, which is at 0, and so that'd be where it's undefined. So basically, if I looked at the graph for this, it looks like this, and then it's a parabola on this end. And so this is where it's undefined on the derivative. And then we're also going to have a minimum right there. So analyze graph, minimum between here and here is 1.6. Comma negative 3.28. Now the 1.6 you need to make as a fraction. So 1.6 menu number fraction is 8/5. And so that'd be x equal 8/5. So there's your x equal 8/5 is your critical point. Your local maxima would be the 0, 0, because we saw that was a maximum on the interval. So it wants an ordered pair here, which is 0, 0. And then I guess I kind of wrote the minimum value up here at the very top. It just wants more decimal places. It says round to the thousandth, and so that would have been 1.6 comma negative 3.283. So basically it was like 1.600 and so forth. So we don't write those extra zeros, we just put 1.6 and then negative 3.2831, negative 3.2831. And so based on the 1, we round down. So that's your answer. Okay, on this one we're also going to graph. So we have 6x square root of 64 minus x squared. Okay, and then I'm going to do menu 4a. So graph and then menu 4a provides a good window. And so then I know that I have a minimum here and I have a maximum there. So where it would be undefined is at the minimum. Between here and here. Well, it's undefined at the edge and at this edge, which is plus and minus 8. So basically negative 8 comma 8. It's the domain endpoint. So on this one we have from negative 8 or negative 8 comma 8. And then for the f prime to be 0, that's where it's a minimum or a maximum. And when I did the minimum earlier, I got negative 5.66 approximately. But we'll need that as a exact answer. So since we need the exact answer, we have to do the work for it. So we have y equals 6x square root 64 minus x squared, and you want to use your product rule and call this u and call this v. So y prime would be v times u prime plus u times v prime. And so the v is the square root of 64 minus x squared, and then the derivative of 6x would be 6. I'm going to put that in the front. And then the u function is the 6x. And then the v prime part is like this. If this v is 64 minus x squared to the 1/2, that means it would be 1/2 64 minus x squared to the negative 1/2 and a negative 2 in the back. The reason for the negative 2 is because it's negative 1 times 2. So basically the derivative of the inside. So that's what we need over here. So this is 6x times all that stuff. Well, the 1/2 times negative 2 cancels, except for we need to change the sign. And then we just put the 64 minus x squared on bottom. Okay, like that. Then what we do is we multiply by this to get a common denominator. And so when we do that to this side, it's 6 times the square root of the exact same thing, so the square roots go away. So you just have 64 minus x squared, and then minus 6x all over the square root of 64 minus x squared. So then we just need to distribute 6 times 64 is 384. So you have 384 minus 6x squared minus 6x all over square root of 64 minus x squared. Okay, let's just take one step back. Up here, when I did the derivative of negative x squared is negative 2, I meant negative 2x right there. Sorry about that. And so then based on that, I need a squared here, and a squared here, and then a squared here, because those needed to be like terms for this to work out. So I basically have 384 minus 12x squared over square root of 64 minus x squared. So then what you do is you set your numerator equal to 0. Well, really all of it. And so we have 384 equal 12x squared, because I'm just moving that over, and then divide by 12, and so this would end up being 32 equal x squared. Okay, so when we do this, your square root of 32 is really like the square root of 16 times square root of 2, so that would be 4 square root of 2, and that's going to be your exact answer. So if you want to save a lot of time, guess and check, and 4 square root of 2 would be the same as your 5.65, and so on. So you need that exact answer. So this would be positive and negative 4 square root of 2. And then your local maxima would be back on this left side. That's a maxima, negative 8, 0. And then the other one would be at this one, which is the positive 4 square root of 2, comma 192. So it's symmetric. This one was with negative 192, and this one is with positive 192. There's the positive 192. Okay, and then the minima would be this point and this point. So that would be your 8, 0 and negative 4 square root of 2, comma negative 192. So again, the max was at the negative 8, and the min was at the positive 8. And then your 4 square root of 2 just have different signs, and your 192 has different signs. Okay, so that was the last question in 4.1. Now we're moving to 4.2, and on this one we have 6x plus 6 over x, and our interval is from 1/6 to 6. So we're going to want f of 6 minus f of 1/6 over 6 minus 1/6. And for this one, I would recommend just typing this in here, 6x plus 6 divided by x. Go to your table and change your setting to be independent to ask, and put 6 and put 1/6, and in both cases you get 37. So this would be 37 minus 37 over 6 minus 1/6 is 35/6. And so you get 0 for that. Okay, So now we need the f prime part, and so the derivative of 6x would be 6. I just rewrote 6 over x as 6x to the negative 1. So the derivative of 6x is 6, and the derivative of this side would be negative 6 over x squared. Remember, when you're making it a negative 2 power, that's the same as just making it into a denominator. So now we set these terms equal to each other. So 6 minus 6 over x squared equals 0. I would recommend moving this to the right, so you get 6 equals 6 over x squared, and then just solve. So you multiply by x squared and then divide by 6, and it cancels, so you're going to get 1, and then that would be plus and minus 1. And then based on 1/6 to 6, use positive 1. So C is 1. On this one, you're going to want to graph and see if it's continuous. So basically we go to a piecewise function. So this to the right of the 9, and you have a 2 by 2. And this part is the x squared minus x, and this part is 2x squared minus 2x minus 2. So this interval would be negative 2 less than or equal to x less than or equal to negative 1, and this one would be negative 1 less than or equal to, or no, just less than x, because it can't be for both. So negative 1 less than x less than or equal to 0. Oh, I made a syntax error. I forgot my x. There we go. Okay, so it is a little crooked, but it's continuous. So that's to be expected on this particular one. Sometimes they're not continuous, and it has a jump discontinuity. But on this one, it is continuous on the closed interval, and it's also let's see, is it differentiable at every point? So in this case, even though it's looks continuous, it's not differentiable at the break. So I wrote down the derivatives. It would have been 2x minus 1 and 4x minus 2, which is really irrelevant. But it's not differentiable at x equal negative 1, because that's our boundary point, basically. And the negative 1 to 0, I mean the negative 2 to 0 includes that point. So basically it is continuous at every point, but it's not differentiable. So is continuous. Now whenever you're doing continuous or continuity, you need your brackets, not parentheses. So you need the brackets, and so that'd be A. Okay, on this one we have f prime of x equal 2x, and we want to find f of 5 for this ordered pair, 0, 0, and for 4, 13, and for negative 1, 5. So for part A, f0 equals 0 implies you're going to have g of 0 plus c, and we already know that would be 0 plus c. And when we have a derivative given to be 2x, then the function would be x squared, because you put your 2 to the top. And so this would be like x squared plus 0. And now we want f of 5, so f of 5 equals 5 squared, which is 25. On our next one, we have f of 4 equal 13. So that would be g of 4 plus c, and we know g of 4 would be 13, so 13 plus c. Okay, for part B, I found out an easier way to write it. So the easier way to write it is just putting 4 squared plus c, because our f was x squared. So we put 4 squared plus c, and we set it equal to 13, because 13 is our y value. And then 4 squared is 16. 13 minus 16 is negative 3. So based on that, we have x squared minus 3 for our function, and then we want f of 5, and so we do 5 squared minus 3, or 22. So basically 25 minus 3 is 22. And then let's do that for c also. So on this one we have f of negative 1 equal 5. So we're going to have negative 1 squared plus c equal 5. So that's 1 plus c equal 5, so c is 4. So basically 25 plus 4 is 29. That's this answer. Okay, so for our next one, it says find all possible functions with the given derivative. So on this one, since we have x to the 9th, you're going to do the antiderivative basically and go up to the 10th power. So you'd have x to the 10th over 10 plus c. So basically think of it as it has to be bigger by 1 and then that fraction, like 1/10. Or just x to the 10 over 10. So since it says all possible, make sure you have the plus c, because the derivative of any constant would be 0, which doesn't exist. And to check it, think of 1/10 x to the 10th as your function, and then when you do your derivative, you do 10 times 1/10 x to the 9th. So that cancels, so you get x to the 9th. And so that's why you're going to get the same number on top and bottom. It's x to the number over the number. Okay, and then on this one, when you're working backwards like this, because you're already given the derivative, this would have to be x squared minus 5x plus c. Now the question is, what is c? And so think of plugging in 0. If you plug in 0 to there and there, then this has to be 2 for f of 0 to be 2, or p of 0. So that means over here we'll put x squared minus 5x plus 2. So that way we found out what our c had to be, and it's based on the y value. Okay, on this one, it's your last one. For acceleration, you need to use e to the x like we did in the homework. So we have acceleration, which is the same thing as your derivative of the velocity, would be e to the t. Your velocity would have to be e to the t plus c, and at v equal to 10 and t equal to 0, you'd have to work out the equation 10 equal e to the 0 plus c. E to the 0 would be 1, because anything to the 0 power is 1. And so you're going to get 9 equals c. So you have velocity equal e to the t plus 9. Okay, so this will be very quick. Short explanation, don't use e to the x. The reason is because when I made this video, the numbering was all weird, and this one says a is 32 and v of 0 is 20 and s of 0 is 5, and in the document that I was using to make the video, that problem was not in here, and the numbering was all weird and everything, and so that was not the right way to do it. And so there is a much easier way. It's actually really simple once you understand it. So we start with a is 32, and then v had to be 32t plus c, and then you plug in v of 0 is 10, so put 10 equal 32 times 0 plus c, so 10 is equal to c. That means you turn into this equation, v equal 32t plus 10, and then if you need 32, we need to do 16 times 2, so we have 16t squared plus 10t plus c, and then figure out it's 4. Now, once you understand this, you'll actually see it's really easy. What we were given was that a was 32, v of 0 was 10, and s of 0 was 4. And so if you just remember, change the 32 part in the front to 16t squared, then these numbers are going to stay the same. And it's like super easy. So 10, so it's 10t, 4, and so you got 4. Alright, that's the end of the video.